Recording. Thank you, gentlemen, for coming today. I know it's snowy outside, and if you don't know me, my name is Chad Kirdy. If you guys have forgotten, um, over the last week or so of not lecturing, and you missed my lectures, I'm sure. Um, you just laughing here. Okay, here's what I have for you guys. I do have, excuse me, two examples about banking transformers. I think you guys being as professional as you are, you need to know how to analyze transformers as in finding the conductors and overcomputation device for transformers. So this is what we're going to do today. And then I have two examples, and then I do have also the second section. I'm hoping I have another center tab transformer. So two examples about Delta-wye transformers and one example or two examples about center tab. So let's go ahead and start. So we're going to go ahead and start, my friends. Here's the system that I have. So let's go ahead and draw the system. This is my system.
What are you doing with Delta-wye?
It's a delta and a miss y. Not y, I have to say the miss y. Delta and miss y. Okay, so I have a Delta-wye transformer, my friends. And on the primary side, it's a 480 volt. On the secondary side is a 208/120 volt. And I do have my beautiful neutral coming in here tied to Mother Earth. So this is phase A, neutral, phase B and phase C. This is phase A and neutral. Phase A, no neutral here, right? Phase A, B, and C. So this is my transformer, guys. The only difference for this transformer is actually a banked transformer. So I'm going to say this is example number one. Example number one, just FYI. Oops. Example number one. I'm banking three transformers to create a single phase. Three single-phase transformers to create a three-phase system. Just a quick reminder, guys, when we bank transformers, this is how they look like. Transformer number one, transformer number two, transformer number three. You guys remember how we did it with Mr. Ryman and with Chad? I'm going to quick remind you. And from this side, we have 1, 2, 1, 2, 1, 2. These are, guys, three single-phase transformers. And I want to bank them. Do you remember how we bank transformers? We hook them up as a bank to give us three-phase system. Three single-phase transformers hooked up to give me a three-phase system. Commonly, not a whole lot of common, but you can use it. Morning, Mr. Bab. Morning, sir. And it's used in mostly high industrial projects. So let me go hook up, guys, the primary side. The primary side, look at that, how we hook them up. We connect these two together. Can you guys see with me? Connect these two together on the primary side. This is my high voltage, H1, H2, H1, H2, H1, H2. The high voltage side. And guess what we do? We bring a phase, here's phase A, here's phase B, and here's phase C. Let's just take it all the way, phase B. Phase A, B, and C. And the connection is right here. I want to just make sure that you know where the connection is. So here's how you hook up a delta on the primary side of a transformer. We hooked up a delta, the high voltage, a delta. We series the coils. Do you guys remember how we did that? We series the coils. Without giving it too much details, this is the coil. Here's a coil. Here's a coil, how we series them. And then we bring a phase between every two coils. Any question, guys, about connecting them as a delta? Can you guys see how it's a delta transformer?
Do the phases have to be in the exact order?
No, they're usually ABC from right to left. It's adjustment. They have an order for them, but let's just make them in the order right to left like we always do, just to make it clearer. There you go. And where did they went from here to here? Okay, let's just make this one phase E, just to make it a little bit clearer. I'll give you enough time to phase A, and I went and I put from here phase B, and from here phase C. Okay? And don't forget, okay. So I have phase A, B, and C on the primary side. Any question guys about the primary? Let's do the secondary. On the secondary side, my friends, I want to go ahead and connect these as a Y. How do you connect? This is usually X1, X2, X1, X2, X1, X2. Who the heck is, what are X's and what are H's? These are the convention for the primary, the high voltage and the low voltage of any transformer. X's are low voltage, H's are high voltage. Okay? So if you were to connect these guys as a Y, you guys remember how we did it? We did it with me and we did it with Ryman. You connect all these all X1s, all the X1s, and you bring them to, and you ground them. So this will be my neutral, and then you bring let's use a different color here. We bring phase A, phase B, and phase C. So we take all the X's to the neutral, and we bring the phase A, phase B to X2, X2, X2. The X2s go to the phases, the X1s all tied together and go to the neutral. Go to the neutral. Any question guys about what we're doing here? We're banking a 3 transformers to get us a 3-phase system. And oh, by the way, my friends, I want you to know that this will actually 50 kVA. This is also 50 kVA. This is 50 kVA. So 3 transformer banked together. And this is where
the Delta one, Chad?
this is the one. Hold a second here. This is my. Go ahead.
Come out the Delta one.
This is that part. The top is a delta. The bottom is a Y. The top is a delta. The bottom is a Y. This is actual wiring. How they're wired, guys. Actually in the field. This is how the schematics for them. The top one, both the top and the bottom are the same. This graphic is the schematics. The second one is the actual wiring in the field. So Spencer, my friend, this little rectangle here is actually a barrel, a transformer. Here's a transformer. It looks like this one with 2 wires coming from the top and 2 wires from the bottom right here. High voltage 2 here and 2 right here, low voltage. Does that make sense, guys? Single phase transformers banked together. Okay, so we're gonna find a few things for this single phase transformer, guys. A few things, my friends. Oops. It's always the email. No email. No email. Mr. Beb is paying for my attention. Any question, guys, about the transformer? 50, 50, 50. So, Camille, here's a 50 transformer, another 50, a third 50. What do you guys think the bank together would be? Thank you, 150. Okay. So, can you guys look at the transformer now? So knowing this transformer, we need to go and answer a few questions about this transformer. Are you almost there, Mr. Bab?
Yes, sir.
Are you recording me?
Yeah, I'm just.
Every day.
One can't do a little crime anymore and get away with it. All these recorded. Okay, any question guys about the schematics of the transformer? I want you guys to look at it, so we're going to answer a few questions about it. We have to answer basically 13 things about it. Some of them are very easy, you're going to find 13 things. Let's start while Mr. Bab is copying it. If I ask you what's the voltage line to line on the primary? Quick, voltage line to line on the primary. 480. What's the voltage, phase voltage on the primary? Everybody knows what the phase voltage on the primary. The voltage, phase voltage on the primary. 480, it's the same. It's a delta, guys, if you forget that one. In a delta, the phase and the line are the same. This is the first and last time you're going to hear Chad Kearney talk about this, and then we'll kick you guys out to the industry. and you only deal with with the line voltage. Okay, on the primary side, everybody can see that the line voltage is 480. And what's the phase voltage? A phase voltage, guys, is a phase across the, if you guys have forgotten, the line voltage, let's do it on the primary side. The line voltage is this voltage from here to here. The phase voltage is this voltage from here to here. This is V coil, and this is V line. Okay, V coil and V line. And I don't know about you, Camille, my friend. If you look at these, the V line and the V coil are exactly the same, right? Across the same coil. Does it matter that there's a wire between them here? Would it make a difference? Tiny little wire? No. Any question, my friends? Any question about this? Any questions? Okay, Mr. Bab?
Yes, sir, go ahead. Yeah.
We'll have to go ahead a little bit. Okay, number one. Here's what do I need you to do? That's always the question. Chad, what do you need us to do with this? Number one, my friends, I need you to find banked KVA. What is the banked KVA? What's the banked KVA? How many transformers do I have? Yeah, the total transformers. So I have 50K plus 50K plus 50K. So the banked transformer is 150 kVA. The banked is 150 kVA. Any question, guys? Add them all three together. Piece of cake. Number two. The banked kVA. Add them up. Let's find primary line voltage. Primary line voltage, I'm going to call it V primary line equal. What's the voltage the V primary line equal? V primary line. Anybody can remember? The V primary line.
480.
Thank you. 480. No gimmicks, nothing. 4, 8, and a 0. Oops. Let's use a convention here. It's a 4, 8, oops. There you go. 480. 480. Okay? 480. One, two, three, my friends. 3. I want to find a primary coil voltage or phase voltage. What's the primary coil voltage or phase voltage, guys?
480.
On the primary, it's a delta 480. So piece of cake, thank you. V primary coil equal V primary line. This is a coil, believe it or not. V primary coil equal V primary line equal 480 volt. Any question, guys? The primary voltage and why? Anybody knows why? It's a delta. That's a piece of cake, right? It's a delta. Any question, guys, about the primary? These should be second nature to all of you. Number 4, let's go to the secondary side. Secondary line voltage. What is the secondary line voltage? Secondary line voltage. 2A, thank you. It's a line to line. The secondary line voltage, which is V secondary line equal 208 volt. Oops. Equal 208 volt. Equal voltage secondary line equal 208 volt. Anybody has any question, any comments about this one? So the secondary voltage, guys, line to line is 208. As long as we're on it, let's do the number 5. Number 5 would be, my friend, secondary secondary coil voltage. What's the secondary coil voltage? Thank you. V secondary coil equal 120 volt. Anybody knows why? It's the voltage, thank you, Bill, my friend, by the square root, or the voltage to ground. The voltage to ground. 120. 120. Any question guys about this? This is a refresher. A refresher, guys. I know we covered some of this stuff. This is a refresher of how transformers are before we get into sizing other things. This is a refresher. Just keep this in mind. This is a refresher. What's the line voltage? What's the coil voltage? So we know how to use it. Any questions so far?
We have cover terms or any of that stuff.
No, no. We did that one long time ago. It's the only thing I care right now is just the voltage because I'm going to use them to size the cables. Okay. Can I move guys to the second one? Okay. So which number are we on? We are number 5. Number 6. Let's go to number 6. Number 6, I need the current. Primary current. Primary current, basically. Okay, what's the primary current? I primary current, I primary equal. Anybody can tell me what's the primary current of that system?
0.2 by it. I got 0.02.
60.2.
You're going to take the, what's the kVA of the system? kVA divided by 1.73 times the primary line equal 150K divided by 1.73 3 times, what's the voltage? 480. And what's the current? Don't forget to multiply by 1,000 because there's a K. What's the current on that one, guys? 416. Anybody came up with?
100.
No, not 1416. 180.
I got 180, yeah.
Thank you. 180. 180 amps. 180 amps. Any question, guys, about this? 180 amps. 180 amps. Since you guys are smart, we're going to do number 7 is going to be secondary current. Secondary, and I'm sorry, I should put here, I put line. So you guys put line current, and the same thing, secondary line current. Line current. Again, what's a secondary line current, guys? I, and this, by the way, this is a primary line. This is secondary line. You guys change this one, the current that we just found on the primary side is called primary line, the one that goes through the line. Okay, secondary line, what do you guys do? The same thing, kVA divided by 1.73 times V, which type? Secondary line. Always line to line. 150K divided by 1.73 times, what's the voltage on the primary? And that will get you, my friends, a healthy 416. Anybody came up with different? 416 amps. 416. 416. Any question about this, guys? So we find the primary current and the secondary current. Can you guys do me a favor? When you find this, can you put a little asterisk next to them right here? The reason why I do this, because these are the ones that are going to be sizing the fuses and the disconnects and the cables based on these conductors. That's how I size the fuses and circuits and so forth.
What's the secondary primary current? Do you know that?
primary line current, secondary line current. We're gonna find the primary coil current and the secondary coil current. Number 8, we're gonna find primary.
Isn't that when you run at
Coil.
417?
What did you come at 417? What did you guys come up with here?
416.28.
Okay, let's make it 4.7. Let's say that. Everybody came up with that?
417, yeah.
So fine with me. 417 M. 417 M. Not gonna lose each other over an M, are we? Okay, the coil, the primary coil, guys, in a delta, the I primary coil always equal I primary line divided by what? 1.73 equal. Let's go all the way to, what's the current that we found? I primary. 180 divided by 1.73 equal
104.
104. Anybody came up with something different? 104. 104. And as long as we're on it, if we go to number 9, let's find primary coil,
Secondary coil.
secondary. Are you awake today? What's going on here, man? Or am I sleeping? Secondary coil current.
That should be 417.
Secondary coil current.
417.
Thank you. What would you? Y.
Because it's Y.
Thank you. I. Secondary. I. Secondary line. I secondary coil. I secondary coil equal I secondary line equal 417 M. Thank you, my friends. The two things that we did here is called mental exercise. These two are mental exercise.
Where did you get from the 180?
The 180 Sir is the line current
Oh, I see. Okay.
on the primary
Thank
side.
you. Thank you.
Any question, guys, about this? Any question about this? Any question? And I know this is not the first time we've done that, so it seems it's stuck in your mind. That's great. You're not going to hear Chad talking about it again. But I just want to make sure before we move into sizing stuff, we know what we're doing. Ready? Cool. Okay, let's go to, so we got the currents, we got the voltages. Number 10, guys, I still want you to know something called transformer ratio. Transformer ratio, guys, is defined. This is defined as V primary coil over V secondary coil, coil to coil. So what's the primary coil? 480 divide, what's the secondary coil? 120. What would that give you guys? 480 divided by 120. 4. And from here, what do you get? 4 to 1. So what's the ratio of this transformer? What's the ratio of this transformer? 4 to 1. Any question, guys, about transformer ratio? The last one in the transformer is 11. There's something called a transformation ratio. This is defined as following all the time. Defined as V primary line over V secondary line. Line over line. Okay, let's take it. 480 divided by 208. Can you see the difference? What's 480 divided by 208? Thank you, 2.3. And if you want to write it as a ratio, it becomes 2.3 to 1. 2.3 to 1. Any question, guys, about this? Transformer. Transformer takes the current from one side to another. Transformation, guys, they use it to transform the power. So two concepts. From your point of view, Spencer, these are FYI. Later on, we're going to be, the most important things is sizing the cables from our point of view. But remember the transformer, transformation, the definition of these two. Now grab your code book and let's go size, my friends.
Sure.
416. We're gonna go size feeders for this transformer. Number 11, number 12. Primary feeder size. Primary feeder size. How do we size a primary with transformer, my friends? How do you size a primary with transformer?
Very good.
Other than very carefully. How do you size a transformer? The primary. Which amps?
Primary, the largest, the secondary.
But we're looking at the primary feeder, so the feeder coming to the primary. Okay. What's the primary? What is the primary current, guys? The primary current. So I, primary line. What was the current, the primary current? 180. 180 amps. You're going to start with I primary current, 180. Okay. Now you have a decision to make, Brooks. Are you going to be considering this a continuous load, or have you calculated the continuous load, already incorporated the continuous load in it? If you are to consider continuous load, what do you guys think we do with this? Times what? 1.25 and you size the conductor. That's kind of the worst scenario. If we already, when we came up with the size of a transformer, guys, if the continuous load is incorporated in it, as in, we already added the 1.25 right into the load, then we don't have to multiply by 1.25.
You mean like if there's a bunch of motors, if you already
Yeah, remember how we
consider
did?
the conductor?
Yeah, when you size 4 motors, you took your motors multiplied by 1.25 plus all your lights, 1.25 plus everything else. Oops, we came up with 140 kVA that we need. We made it 150. So all the 125 is already incorporated in that. We're going to assume this way, guys. So we're going to assume that the 1.25 and the continuous load is already incorporated in that. And I'm going to go size this directly on the primary side, directly based on the current. 180, we're going to go to 310.16, which column and why? 75-degree column, Celsius. And how many conductors? How many conductors? We're on the primary side. We're on the primary side. How many? 3 conductors. Why 3?
3 phase?
3 phase. Thank you. Where's the neutral?
There isn't one.
No neutral on the primary. Okay. And the conductor size would be in a case like this? 3 odd. Conductor would be 3 odd. The conductor will be 3 odd. The conductor will be 3 odd. Any question, guys, about this? Any question?
Sorry, Chad, I just missed something here. So the 180, we're not dividing that by 3, right?
No. No. Each one of the 3 phase will be
180.
Yep, 180 amps. The only question I wanted to have a disclaimer here. Sometimes you multiply this by 1.25 if you have not taken that 25% increase when you size your system. Okay? 12. I'm going to do 12 right in here, guys. And I mean 13. 13, I want to call it secondary feeder size. Secondary feeder size. Okay, what's the secondary? You go I, secondary line. Now, Mr. Erbab, do we use the line or the coil current on the secondary? Or are they the same? On the secondary, they're the same. We always, when we size cables, guys, and fuses, we always use the line current and the line voltage. Okay, I secondary line. What's the current? Thank you. 417 amp. We're going to take it all the way to which table and why? 310.16, which column? 75 degree. Why, by the way, why 75 degree?
Over 100.
Thank you. Over 100. The rules is over 100. 75. How many conductors and why? How many conductors and why? We're going to carry full neutral. We're not going to derate. You can derate. We're going to carry full neutral. 4 conductors. Why 4 conductors? We have a full neutral. And 4 conductors. And what's the size? 600. Thank you. 600. 600 kcm. Any question, guys, about this? So we took the most important, Spencer, the most important thing in what we did so far, from an electrical point of view, is these 2 valves. That's what you're going to go size the cables as a designer, right? So we size the cables on the primary and the secondary. All these voltages and transformation, this is just to get you guys to understand how are you going to connect these systems. Mr. Erbab, does it make sense?
Yeah, yeah.
The primary feeder size, the secondary feeder size. The last, good.
I just wondering if we're confused or anything.
Yes, we're going to fuse it. The last thing we're going to do, guys, we're going to fuse them. The last thing I'm going to do, I'm going to fuse them. So as you know, you have to fuse it. Fuse it. Fuse it. I want to fuse on the primary and on the secondary. Okay. Everybody knows where the cables are. The fuses are going to be located on the primary and the secondary. And you guys are pros now. 13, 14, go ahead. 14. Number 14, my friends. We're going to go ahead and size primary overcurrent protection device, and I want to use a fuse. Primary overcurrent protection device, my friends, I want to use a fuse. For this one, we're going to go to, do you guys remember the table 450.3b? Thank you. You're still here. We're going to go to, okay, we're going to use I, primary line, which was 180 amps.
Are we going to fuse both or just the primary?
We're doing the primary and we'll do the secondary next.
What is the code?
The code is
Okay.
450.3b. If you guys go to 450.3b, what's the multiplier from 450.3b if the transformer has a primary and secondary multiplier and a fuse? 2.5. We used this table before. This is a review, guys. So we have a 450. My table is 450. That I'm going to be going to. So 450.3b. Okay, so I'm going to take, then in a case like this, my friends, I'm going to take my 180, multiply it by what? 2.5. What would you get? When you multiply it by 1.5, you get 450. You guys came up with 450? Come up with something different? Come up with 450?
Yeah, I got 450.
450 amp. Then you're going to take your 450 amp to where? 240.6. Is 450 amp a standard fuse? Is 450 amp a standard fuse? Yes. So it's gonna stick with 450. Yeah. If it's not a standard, what would you guys do?
Go up,
Go up or down?
down.
Down. Does it say? Does it have a note that says go up underneath the table? Note number 1. If it doesn't have a note that says go up, so what are you gonna do? Custom design yourself a fuse. Go to the bar and cry like we said, or you're gonna go down. You're gonna go down.
But it says,
See note number 3. Doesn't say anything about inherently and all this good stuff. So if it has note number 1, guys, then you go up. No note number 1, you go down. Any question, guys? So done. You size the fuse. You size the fuse. This is also, Ben, my friend, is very important for us. This value is very important for us. Very important for us. So 450. If it doesn't have note 1,
How do we know that that's not number 1?
it's right underneath it and next to it. You have your code, Mr. Bear? Get your code. Get
Yeah, just for the
page 337. What happened to it? You left in North Dakota?
Just left it
Ah.
in my home. Sorry.
450.
Yeah, okay.
You used it to get the carburetor fire out from the oil.
15. And the last thing, I believe.
Secondary overcurrent protection.
Thank you. Secondary overcurrent protection device. Again, fuse. We're gonna go, guys, to the same table. 450.3b. Okay, what's the I secondary line? I secondary line equal what? 417 amp. Okay. Now from here, you're going to take the 417 multiplied by what's the multiplier?
1.25.
1.25. Why 1.25?
Because the code book says so.
Because the code book says so, not Chad.
521.
520. 21?
Yeah.
521 amp. Then you're going to take the 5 at 21 amp. Where's my Bible? 240.6. And if it's not a standard, you go up. Why do you go up on this one? Because the code says there's not number 1. If you don't hit a standard, you can go to the next standard up. What's the next standard up for 5221? Do we have 550, Brooks? We don't have 550. So what's our next standard? 600 amp. What's my next standard? 600 amp. The reason why I bring the transformer, guys, because we are going to be sizing transformer in your building, the commercial building. We're going to have a 480 208/120 transformer to feed the panel, the receptacle panel. That's how we size this transformer. So we need to understand how to size the transformer. All the stuff that I told you, voltage, primary, and secondary, that's just warming up. What the important stuff is what I'm going to put that red asterisk next to it. This is important. This is how we're going to size overcurrent protection device for this transformer. Primary, secondary. So Spencer, really 3 things you need to know. 4 things out of the whole mess. The feeders on the primary and secondary sizes, and the overcurrent protection device on the primary and secondary, done. The rest is just warming up and getting you into the business.
Will you read that note 3? It doesn't make sense.
Note number 3. Note number 3, it says a transformer equipped with coordinated thermal overload protection by manufacturer. If your transformer has an overload inherently designed part of it, a thermal protection, then if you read through it, then you take this was for note number 3. Then you take the full load current and you multiply it by 6 times. That's note number 3. Unless you know, though, you don't use this note. So if I told you my transformer is inherently protected and coordinated and all this good stuff, so then I can take and I have then I have a 100 amp fuse on the primary. 100 amp. Say I have a 100 amp transformer on the primary side. 100 times 6 is what? 600. Then I can put a 600 amp fuse on it. They allow you to go so high based on not 3, if the transformer has an inherently coordinated overcurrent protection. But the assumption is not unless you prove otherwise.
So then why did they use this for the table right here?
Yeah, because if you know that a transformer has, if you know that a transformer has this type of protection, then you can go and instead. Remember how we came up on the primary side? What size that we came on the primary side? 450. Now let me tell you. Let's just say, just for my friend, let's just say this transformer was inherently protected, like it says, thermal protection. Then take the 180 times it by 6 for me, will you? 180 times 6. 180 times 6.
1080,
10,
1080.
1080. You can't go up. What's the next standard down? 1000. I can up this one to a 1000 amp
Oh,
at this particular transformer, but we don't know that we have this particular
that's
transformer.
only if it's got that in here.
Absolutely.
Okay.
Thermal protection.
And most of them have them.
Up to my knowledge, no. So your assumption is what Chad is doing, unless you know otherwise. Good question, though.
Thanks, I stayed up late last night. Thought about it.
Any question, guys, about this? Any question about this? Camille? Cool? You're gonna hear Chad again talking about this. Okay, I'm gonna have as a matter of fact, I do have a 16, which is the last one for you. 16 as available short circuit at secondary. What's the available short circuit at the secondary? What's the available short circuit at the secondary, and why do I care? This is a big deal. To solve this one, guys, I want to take you all the way back, please, and I want to tell you that these transformers, when they bank, they have an impedance. Let's see, what impedance did we use here? Let's say the transformers, let's say they have an impedance of 5%. Z. The Z for this bank is 5%, okay? Just put 5%, given, always given. So if the Z, the impedance is 5%, Mr. Erbab, and I need to find the available short circuit at the secondary side, then I'm going to say I, let me use my convention, I, oops, not this convention, I short circuit equal I secondary line divided by Z, the impedance. What's I secondary side? 417. Divide, what's the impedance in decimal? 0.05. Anybody can give me the answer for this? 417 divide 8,340. 8,340. 8,000.3 K. Kilo amp. Always in K's, guys.
If that's 18 or 8,000.
Did you say 8 or 18? Where did they get the 18 then? What's going on here? 8.3 kilo amp, the available short circuit, and this is at secondary. If I ask you at the primary, you can't find it. The primary, guys, you can't find it. This rule does not apply on the primary, always on the secondary. Who cares? Now, Brooks, any circuit breaker on the line side of the main, I can be rated for 10 kilo amp. If it's rated for 10 kilo amp, that's okay. Why? Because available short circuit is what? 8.3. Yes, sir.
Impedance comes from the coil.
A coil. The higher the impedance, guys, the better, because the least amount of short circuit it allows to go through. Well, no, yes, but the lower, but then the disadvantage is a voltage drop. Higher, voltage drop goes up, current goes down. So there's advantage and disadvantage of it. Please highlight this one. This is also another important value too, though. The ones that has that red asterisk next to them are the most important things, guys, from a design point of view.
Does it matter if it's a dry or gel transformer? It's all the same.
The type of the calculation doesn't matter. If you go to oil transformer, they have a few way of calculating them.
Oh, did you change?
Oil
it a little bit?
transformers.
Okay.
Well, this will apply to them, but we follow the manufacturer's recommendation mostly. If you have a 2 meg, 20 meg transformer, the same calculation, but you can apply the same calculation for a 2 meg transformer.
Okay.
But remember, the primary is going to be different voltage. Any question, guys, about this? Any question about this? How about if I give you guys 5 minutes and I'm going to go over one more example? So let's take another example, this time with medium voltage, my friends. I want to take this example, and please, here's my example, the same thing. Don't forget that there will be fuses here, fuses. There will be fuses. This transformer, my friend, on the primary side is 13.8 kV. On the secondary side, we're going to make it a 480/277 volt. I have a transformer, and I have my neutral. This is phase A, neutral, phase B, phase C. This is phase A, phase B, phase C. The impedance of this transformer is going to be, let's just say this transformer has a 6% impedance. Z, right into it. Okay, I do have, guys, a transformer banked. All these are banked. I'm using a banked transformer, and the bank that I'm using here, each one of them is 75. This one is actually 75K. This is 75K VA, V and A, 75K VA. I'm using a 3 single-phase transformer banked together in a single-phase, in a 3-phase system, and I need to do the same thing. I'm not going to draw, guys, the little connection. You're familiar with it now. But if you connect them, you put 3 barrels side by side. You tie them delta from the primary. From the secondary side, it will be a Y. Okay, so this is my example number 2. Let me see, where am I going to put that one here? Example number 2.
So you're saying that you're like 120 volts coming in, and you're using 320 volt.
I'm using 13,800 volt on the primary.
Different banks,
Yeah,
transformers,
Yeah.
so one for each phase.
line to line. When you bank them, that's what you get, line to line. But to draw how it's going to be.
No, I know that thing when it's just, I just don't know. I'll just ask, yeah.
Okay. Any question, guys, about what's the requirement? I have 3 single-phase transformer. I bank them together in a 3-phase system. The primary voltage on the line side is 13.8. The secondary voltage is Y, and it's 482/77. We're going to answer the same questions, guys. Go over the same thing. So I'm going to start with, if you guys remember, number 1. Number 1 was banked. Number 1, banked KVA. What do you guys think the banked KVA for the system is? Each one of them is 750. Anybody, any idea? So 3 times 750 equal what? 225? 225 kVA. 225 kVA. Everybody can see what we did, guys. Each one of them has 75, so the three together make 225 kVA. Make 225 kVA. Number two. Number two. I need to find the voltage primary line. What's the voltage primary line, by the way? Thank you. 13.8 kV. That's piece of cake. Let's do 1, 2, 3. Let's go find V prime, V secondary, just to be consistent. V primary. Let's do V primary coil. What's the voltage on the coil voltage on the primary? Look at it. Thank you. 13.8 piece of cake, Chad. Are you kidding me? 13.8 kVA. kV. Why? Because it's delta, right, guys? Am I right?
Mm-hmm.
Say yes, Chad.
Yes, sir.
1, 2, 3, 4. All right. V primary coil. Let's find V secondary line. What's the line voltage in the secondary? Look at it. What's the line voltage in secondary, guys? 480. Thank you. 480 volts. Perfect. So let me just do the last 5 here. V secondary coil. What's the voltage secondary coil? 277, right? Perfect. Okay. So the first 5 are piece of cake. Piece of cake. No question asked. Any question, guys, about this? Give you a few seconds here to recoup while your friend Chad loading his coffee. I'll leave a coffee that keeps me moving. We're done with this business.
Is this a good spot to do the ratio on this economy?
We'll do them in order. You hold your horses. Any question, guys, about this?
No, sir.
Mr. Beb,
You're
you gonna move?
Yeah, it's okay, sir.
Very party.
Because,
Backward.
yeah.
Yeah. I can't say I wanted to say a smart aleck comment, but we're recording here. Don't lose my job. Number 6. Number 6. So number 5, my friends, we found all these amps. Number 6 is we're going to find I primary current, just to stay constant. I primary line. I primary line, current. What was the bank, guys? 225K. Divide this by 1.73 times, what's the voltage? 13K. Now what would you do? What do you do in a situation like this? 225K divided by 1.73 times 13K. You know what I would do instead of multiplying by the thousands? The K goes with the K, right? Remember, guys, that from the days of the. So take the K with the K. What would you get?
10.4.
9.4. Thank you, bud. You get 9.4 amp. Did you guys see how small? Did you get so different? Amps. Amps. And the reason why it's small, because the voltage is extremely high. Can you guys see it's 9 amps? Less than 10 amp fuse. 9 amps. Can you guys see that? Why? Because the voltage is huge. That's how they can transmit the power from Texas all the way to Minnesota. They pump the voltage so high, the current goes so low, you can you can shuffle, move a huge amount of energy with a very small amount of current if the voltage is high. Eric, my friend, are you doing good? You're so quiet today. Okay, number 6. Number 7. Number 7. We're going to find I secondary line. What's the I secondary line, guys? 225K divided by 1.73 times, what's the voltage in the secondary? What's the voltage in the secondary? 480. On the secondary, DJ, what's the voltage line to line on the secondary?
Why did you use the 325K on the top one?
It's the same 225. The same transformer has a primary and secondary,
Okay.
right? Yeah. What comes in as a power on the primary side must come out as a power on the secondary side, right? That's what transformers do, guys. They don't consume energy. They take the energy, transfer it from one level of current voltage to another level of current voltage.
That changes voltage and upstream.
That's it. Or vice versa. They change the voltage and the current. One up, one down. Or one down, one up. What did we say, guys, about this? 271. 271M. Okay. So this is my I secondary line. Excuse me. Let's do number 8. I primary coil. I primary coil. What do you guys think the I primary coil equal? The 9.4 divided by 1.73. Anybody did that for chat? 5.4. 5.4 amp. Anybody came up with 5.4 amp? Chanel, you are my calculator today.
Yeah, that's correct.
Right? Yeah. Okay. I primary coil. Number 9, piece of cake, guys. I secondary coil this time. The same thing. You take the 271. You know what the formula is now. 1.73.
Where are you getting the numbers from?
These.
Yeah.
This is I primary coil equal I primary line divided by the 1.73. Remember how we wrote that primary? Okay, in this case, what did you guys come up with the other baby?
156.6.
157 amps. Anybody disagree with my friend? Any question, guys, about 9? Any question about 9? So we find, now I want you to highlight 2 things, very important to me and to you. This number here and this number. Spencer, the list, the rest is...
I disagree. I think that's.
Oh, is it? Which one?
Stays the same in the Y. The current does, doesn't it?
I short circuit current.
You're not finding short circuit. You're finding secondary coil.
It's a Y, Chad. Duh. It's a Y. Thank you, guys. I secondary coil equal I secondary line. Good one, Spencer. And it's a 271 M. Thank you. It's in a Y. The current stays the same. Doesn't move. Thank you. Good one. I'm glad one of us is awake today. Yeah, because it's a Y. I forgot it's a Y. 1 delta, 1 Y, guys.
So coil equals a line on the line.
Questions?
Do that on the last exam.
No, the last example we did it right. You want to go check? Because I wrote the formula last time. We have the voltage, we have the coil current. Here you go. See? The secondary coil current, we did them. Because I didn't write the formula this time, trying to be in a hurry. That's why don't ever be in a hurry. Right, Mr. Bell?
Right.
So I secondary coil equal I secondary line. No problem. So this is my 9. Any question, guys, about the currents? Any question about the currents? My Muhammad? Bad roads, man?
Yeah.
I understand. Number 10. Number 10, my friends, is transformer ratio. Transformer ratio, guys, take the 13.8 divided by 277. I, V, not, or make up your mind, Chad, V or I. V, primary line over V, secondary, it's actually coil to coil. This one is coil to coil. So V, primary coil, divided by V, secondary coil. Coil to coil, don't forget that there is a K here. So if you do that, my friends, you're going to end up 50. And if you write it as you should, it should be 50 to 1. Chanel, that's how you're going to write it to me. When I ask for a transformer ratio, you're going to put 50 to 1. 50 to 1.
I would have failed if I put 49.8.
Huh? 49.8?
Yeah, 49.
49. 50,
Yeah,
that's
that's
50.
50, yeah, yeah.
If you write it
Yeah.
49.8, that's
Right.
fine too.
That's 50.
Rough around the edges, man. Any question, guys? Any question? Okay, transformer. The second one, guys, my friends, is 11. Transformation ratio. This one is V primary line over V primary, V secondary line, line to line. V primary line, oh come on, Chad. V primary line over V secondary line, 13.8 divided by 480. 13.8 divided by 480. 29. Up to this point, you didn't answer my question. 29 to 1. Now we're talking. The ratio is 29 to 1. Transformation ratio, Ryan, my friend, they use it to analyze the grid. That's one interest to guys to you. Almost there. Number 11, number 12. Any question about 11 and 12, guys? The transformation ratio. FYI, mental exercise. FYI, mental exercise. No value related to what we do. But mental exercise good. Now we're going to talk primary feeder size. We're going to go size the primary feeder. Okay. Primary feeder size. Now we're talking, Mr. Bev. I want your full undivided attention. You take the I primary line. What was the I primary line, guys?
9.4.
Thank you. I primary line 9.4. Take this one, guys, to which table? Which table?
310, 16.
What's the voltage? 13.8. Table 310-16 doesn't go all the way to 13.8, guys. It goes all the way to 2000. So what you're going to do, we're going to go to a different table. We're going to go to, from this we're going to go to table 310.77. Could you please go to table 310.77 under 90-degree column? If you are sleeping, could you please awake now? Wake up. If you guys go to 310.77, 310.77, these are underground ducts for medium voltage cables. Underground, page 159, 310.77. This is one of the tables that we can use. We can use a lot of tables. This is a commonly used table, guys. I think I walked you through it one time. Let me repeat myself again. Can you guys see there are two sets of columns? One column go all the way to 5K. The other column go all the way from 5, more than 5, up to 35. Can you guys see that? So which column do you think are we under? We're 13.8. So we're going to be between the more than 5 and up to 35. Can you guys see that?
Number 6.
Okay. So how many amps do I have? 9.4. 9.4. I can't use number 8 at this. There's nothing, right? Can you guys see? 8 doesn't give you a value. So skip all the way to 6. 6 can give me 90. Under which? Now you're going to ask me under which column, guys? 90-degree column. Medium voltage brooks, they size them. You can have the termination either 90 or 105. The most common one is 90. So we're going to size. We're looking at 310-77. The top one.
Top left.
The top left, yep. 310-77, top left. The top of it, if you can see, there are two sets of columns. Go to the one that's 501 all the way to 35,000. Under 90-degree column. Can you guys see the 90-degree column? And from there, what's the size of your conductor? The size of a conductor. That's the amp. Amp is 90. Number 6. How many conductors?
3.
3 conductors. Thank you. 3 conductors. Number 6. So we're going to have 3 conductors. Number 6. What type of insulation? Medium voltage dash 90. That's how we're going to write on the test for Chad. Or if you're designing a system, that's how we're going to write it. You're going to say 3 conductor number 6, but this is not any number 6. What's the insulation of this conductor? Medium voltage dash 90. Why 90, not 105? If you don't know, the default is 90. Like 90 is like THHN, Mr. Bill. 90 is THHN. This is a change. This is a change.
What do you mean medium voltage? That's the low voltage?
No, medium voltage is higher than 600 volt.
Oh, I see.
That's a medium voltage, up to 69K. Medium voltage. MV stands for medium voltage dash 90. The installation is rated for 90. So Jim, my friend, you go by yourself. I have them in my office. If you look at my office, I have a couple of these cables. Big, thick, fully insulated for that 13.8 voltage. Since we're talking about cables, guys, I'm going to write a few things that I always like to go over. For cables, there's rating. If you have 5K, guys, you can get a system for 5K. You can get 4160 volt from 5K, and you can get 2400 volt. 15K. You can see that 5K. The rating of medium voltage 5K. If you have a 5K cable, Spencer, the rated is 5K cable. DJ, the cable rated for 5K. You can load it with a voltage, one voltage 4160 and another commonly voltage 2400. Not at the same time. These are the two voltages you can put in a 5K cable. Are you guys with me? If you have a 5K rated cable, medium voltage, you can put the most common voltages that we distribution voltage is 4160 and 2400. If you have 15, the most common ones, guys, for 15 is 13.8. We have 13.8 kV, and the other one is 12.47 kV. 12.47 kV. Okay, if you have 35K, these are K, KV, KV, KV. That will get you 22 kV or 33 kV. Most common ones. Long story short, Brooks, when you work for Excel Energy on your green energy stuff, you're going to encounter, they're going to tell you a 5K cable. 5K cable is good up to what? The most common voltages that you can do. 4160, 4160 volt, and 2400 volt. If you want to go higher system, here's another two higher system. 13.8. 13.8 is 13,800 volt or 12,470 volt. These go with the cable that's rated 15K. Now you need higher cables. The higher cable, 35K, and most likely you're going to end up with 22K system or 33K system. Just FYI, this is not part of the exam, but I thought since we're talking about KV rated KV rated cables, to throw them.
What do you have in the main? What do you get used like in the main down there?
15K. They use 13.8, 15K. 15K is very common. This one, guys, is very common. 15K, and with the cable, it goes 13.8. They call it 13.8. They don't call it even 13. If you the language that they use, they don't say 13,800. They say 13.8.
What's the voltage on the lines running through any given neighborhood in Minneapolis?
4160 or 13.8. A lot of them are 4160 line to
You
line.
won't be able to tell unless you're
Yeah.
experienced lineman by
Yeah,
the diameter.
But the insulation, they tell by the insulation.
It's real small.
Yeah, very small. Remember, guys, the amps. Look at the amps here for the whole cable. 9 amps. You know what a 9 amp says? 9 amp says this. Then the circuit for this sliding circuits,
Why is it when you do things below, they just?
because they're full of energy. You can, guys, you can, Mr. Ben, hold your horses, would you? You can transfer energy, guys, in two ways. You can either increase your amp, or you can increase your voltage, or you can do both. So that's why, yes, it's 9 amps, but it's full of energy because the voltage is so high.
Because the impedance is low.
No, because the voltage is so high, it's carrying more current. You can carry energy, power, in two ways. You pump the voltage up, that's one way, or you can increase the current, that's another way, or both. So if I want, say, if the city of Minneapolis wants to open a neighborhood, or what they have to do, and their distribution system is 4160, so it's loaded, it's max. And instead of changing, well, most of the time, if the installation is okay, they can go in, all what they have to do is just change the transformer in from a 4160 transformer into a 13.8 transformer. That will get you 4 more times power. 4 times more power. Every time you double the voltage, guys, how many times you get power? 4 times. Every time you double the voltage, you get 4 more power. Doesn't matter what the current is. The current is becomes small, but power is the most important thing.
But you have to restring all your poles, right?
Yes, yeah. You have, if you're going within 5K, if you're going from 24 to 41.6, nothing. If you're going from 5K to 15K, then the installation have to change. The cable, the steel, aluminum, bound aluminum. They have a steel wire inside it, and they bound aluminum around it. These transmission lines. That cable is not a big deal. What's a big deal is the insulation where they put the wires on. They are rated for the voltage. So if you have 5K voltage, they put this amount of insulation. If you have 15K voltage, they put this amount of insulation. They keep adding insulation as you tie them to the pole. Anyway, so that's basically a good concept too. Let me, sorry to move you here, Spencer, my friend, but let me move to 12. Any question, guys, about 12? The most important thing, 12, is now you went and resized medium voltage. That's a big deal. You guys will be encountering medium voltage. If you put THF trend here, Bill, you're doomed, my friend. There is no THF trend with these conductors. Okay, 13. Let's go to, what was that, 12?
Secondary.
Let's go 13. Secondary. 13, guys. 13.
So
secondary feeder size. This is also important, so please highlight it. So let's go, what was the secondary current I, secondary line? What was the secondary current? 271, thank you. 271 amps. This is directly 310.16 under which column? 75-degree column. How many conductors on Y? 4 conductors. Y 4 conductors. And how many? What size? 4 conductors. 4 conductors. What do you guys come up with the size? 250. I need another gentleman to disagree or agree with you. How about 300?
Yeah, I went under 75.
300. You should be in the
90 degrees on start.
KCM. What type of insulation? Now we're going to talk about insulation. What type of insulation, guys? THHN. Let's assume it's in a dry location. THHN. Okay, see how we don't use medium voltage cable here. So I have 4 conductors, 300 kcm each, and insulation type is THHN. That's exactly what people Ben are going to hire you to do. Have a transformer, find me the conductor size for this transformer. I want a disclaimer that continuous load is already included in it. If you go, Brooks, to your company and say, no, we multiply this by 1.25, be it. But the way we size the transformer, guys. We come up with the size of a transformer. So what I do when I size the transformer, I take all the continuous load, add them up, plus the non-continuous load, and I come up with my transformer. So my transformer is already oversized for the continuous load. Then I size my conductors this way.
I mean, how else could you design a building where you couldn't do that? I mean, you'd have to always factor in continuous loads at that point of service anyway, right? Or the panels.
We size the
Everything that
transformer.
we calculated back.
Absolutely. For the project that we have, guys, DJ, you're going to size the transformer, the receptacle transformer. And I'll show you later on, guys, as we go through the calculation, show you how to match a transformer to a panel, a receptacle panel to a transformer. We get into that one. Okay, 13. What's next after 13? What comes after 13?
Primary or
14. 14, my friends. 14. Primary overcurrent protection device. I want to use a fuse. Okay, let's say, on which column are we going to use this? Which table are we going to be using? Thank you. We're going to be using 450.3A. Please pay attention to the Miss A. Why A? Why A, guys? Because there is a 13,000. There is a high voltage section. So don't go to 450.3A. And from there, my friends, we will find the primary. What was the primary current? The primary
9.4.
Then this will be 3 times I primary line equal 3 times 9.4 equal, what 3 times 9.4? 28 amps. And does it have
What are you taking out of this?
look at this, you're going to go to 450.3B. Your default is always the first row.
Okay.
And 2 protection, a fuse. We're going to have a fuse. Let's go to 430. 450. Let's go to 450, guys. This table. Can you guys go to 450, please? 450.3A. Page 336. You're going to find, guys, any location and supervised locations. Do we know this is a supervised location? Have I told you that? So you're going to go any location, the first thing. So then no more than 6% impedance. Remember the impedance that I gave you guys? It was 6%. No more than 6. No, in this one I was no more than 6. Okay, what's this? Do we need a primary protection overcurrent protection device over the 600 volt? You can use a circuit breaker or a fuse. What did they say here?
Fuse.
I asked you here, a fuse. So I need to go to a fuse. Can you guys see that?
Yes.
A fuse. Okay, so we have, so what's my multiplier then? Based on the first row under fuse primary. 300. Can you guys see note number 1? What does note number 1 say? If it's not a standard, what do? Go up. So you will take the 28 amps, take it to 240.6. Is this a standard? No, you will go to 30 amps. Why did they go up? Because of note number 1. Note number 1, guys, you go, if you see this arrow here, if it's not a standard, then you go up. Why you go up? Because it says note number 1. Oh, by the way, if you encountered a non-standard fuse, please go up, no problem, it's still safe. Is it wrong to go down? No. On the test, yes.
You encounter what? If you encounter?
If you encounter a non-standard fuse, like 28. Do we have a 28 standard fuse, guys? We don't. So our option is to go to the next standard, which is 30. I can't go to 35 or 40. Only the next standard. Yes, sir?
So the 3 is the 300?
The 3 is 300, yeah. 3% is 300, right? A 3 is a 300%. That's where the 3 came from. Everybody can see where the 3 came from, guys? 300? 300. Okay, so we have 13,
Secondary.
13, 14, 15. My 15, my friends, is secondary overcurrent protection device. Secondary overcurrent protection device. Secondary overcurrent protection device. I'm going to use also a fuse. I have to tell you what type I'm going to use. What's the multiplier, guys, on the secondary over for a fuse? What's the voltage in the secondary? 600 volt or less? Can you guys see from the table? Then what's the multiplier for 600 voltage or less fuse or circuit breaker? What's the multiplier?
1.2.
1.25. So I'm going to take my 1.25, multiply that baby by, what was my primary current? I, secondary line. So 1.25 times I, oops, what's I secondary line, guys, the value?
271.
271. And if you do your math, my friends, and you don't listen to anybody other than your friend Chad, you're going to get 339. 339. Did you guys come up with 100 with this something similar to this? 339 amps. So I have no idea what if this is standard or not. So I'm going to take it 339 amp, take it all the way to 240.6. What's the next standard? Do we have a 350? Do we have a 350? Yep. If we don't, we go to 300. 350 amp fuse. So on the secondary side, guys, we can go and put a 350 amp fuse. 350 amp fuse. How many fuses? 1 per phase. So 3. How many fuses? Always fuses, guys, is 1 per phase. 3 fuses. This is 15. Any question, guys, about overcurrent protection device for the primary and secondary? It should be, let me just write down here because it should be second nature to you guys to go to 450.3a, and this is a table, and this also a table. Don't forget this is table. Yes, Spencer? I'm sorry.
So if we don't have a 350, go to 300.
Yes.
Oh.
No, if we don't have 350, we go up. What's the next standard would be? 400. Did they see? I'm sorry if I said
Well, I was just curious.
No, you go
You're
up.
kind of in the no man's land there.
You go up, always up.
Always
Up. Up is cover yourself type of
What
design.
about the available short circuit?
We're coming.
Oh, okay.
Well, hold your horse. Since when you're becoming running at 60 hertz? I thought you were running at 25.
32 weeks of transformation.
I'm surprised at how the secondary is 350 and the primary is 28 only. I'm surprised at why it's so different. Well,
Because there's
and
40
diffuse.
pins.
The 30 amp primary and 350 secondary. Very good point. If you guys look at this, is tiny little small on the primary side compared to a huge fuse in the secondary, because the voltage in the primary is so huge, Mr. Bell.
Well, the voltage is huge.
It was, what did we say? Was it 50 times when we did the difference between the voltages? 50 times, yeah. Transformation was close to the transformer ratio 50 times. Or if you, transformation is what counts. Like there's 29 more voltages on the primary than the secondary. So there will be 29 less amps on the primary than the secondary. Guys, the concept of the transformer is very huge. You always pump the voltage so high so you can get the current so low. Why do you get the current so low, Mr. Bell? Why do we care about getting the current so low? Because a small current have low voltage drop, and we can shoot it all the way to Texas. A high current is miserable. The bigger the current, guys, the bigger the conductor. The smaller the current, the smaller the conductor. So if I can, here's say, look at this one. Let's say this is 2 meg worth of power. I can transfer this 2 meg, the same 2 meg worth of power with a 13.8 voltage, or I can transform it with 169,000 volt. So the same amount of power, you can transfer it. What's the difference? If it's 169 or 135 is a standard, 135,000 volt, I can shoot it all the way to Mexico. But if I transfer it with 13,800, I might not reach the end of Iowa. What happened after that? The voltage goes so low that you can't transfer the power because of voltage drop. The same amount of power. Increase the voltage so high, the current goes down, you can shoot it longer distances. That's the principle of transmitting power.
That's why we use AC instead of DC, because DC you can't transmit.
The weird thing is at the higher level, after 600,000 volt, they move into DC lines. 1 million DC lines.
Oh, that's all.
They move,
Back again.
yeah, it flips back again to DC. So they have a transmission line. We have a DC transmission line in Minnesota, I believe, here. One DC transmission line. The reason why they go back to transmission, the DC guys, because DC doesn't have impedance. It has only resistance. So when you transmit a DC, you don't have a problem with capacitance, and we don't have problem with inductance, the coil. DC, there is no problem with the coil in DC. So anyway, so they go back to transmitting with, they do it AC, and they convert it at a very high voltage to DC, transform all the way AC up to the voltage 1 million volt, and then they convert the 1 million volt AC to 1 million volt DC, and they shoot it across the country.
Where does it go to, you think?
It goes longer distances. I think there's one coming from up north down to the city. I think there's a DC line. Go to Excel Energy and see, research DC transmission lines. They have DC transmission lines. Any question, guys? The last thing left here, the last thing before I let you go and or eat, is find the short circuit, which is, what was it, number 16, DJ? Number 16, my friend, right? Number 16, short circuit. Short circuit. Circuit current. Short circuit current, I, short circuit. This is always on the secondary. I'm going to say secondary too. Secondary, so to emphasize it, equal I, secondary line over impedance. What was the secondary line? 271, right? Divide by the impedance, was it 0.6? 0.06. 0.06. Anybody can tell me what the answer for this, my friends?
4.5 kA.
4.5 K V K. 4.5 or 45?
4.5, 4,500.
Okay, 4.5 kilo A. Okay, thank you. 4.5 K. So if I'm looking at this transformer, right, my friend, and I will land the cables right in this panel, I can tell that that 10K circuit breaker here is good enough, right? It's a thing rated for 10K, the available is 45K. That's why the short circuit is very important, guys. Okay, emphasize what's mental exercise and what's not. This one is very important, the short circuit, guys. Your friend Chad will walk you through a couple of things. Sizing the overcurrent protection device, this is must know, or you're not a designer. Must know, or you're not a designer. These are the overcurrent protection device. Basically, to summarize, the cables on the primary and secondary, two, and overcurrent protection device, primary and secondary, plus the short circuit. These 5 things must know. The rest of it, mental exercise.
Can you go back for a minute, please?
This one, Mr. Van?
How come we didn't do the primary coil front, no?
We didn't do that?
Yeah,
We did? I thought we did all of them.
we have 16, we did the same
No.
one.
You can go ahead.
We did the primary coil current, primary.
Oh, we did.
That's what I did.
Right.
Any question is, I know we covered this stuff before in 2000, gosh, it's last year probably some of it. I know we did. But I thought to kind of warm you up to the calculation with knowing the transformer. Transformer is a big deal, guys, in our industry. You're not going to hear Chad talking more about these. We're going to shift to a different directions now. But I hope when I say a 3-phase transformer, I hope you know how to find the primary, secondary, and the feeders. That should be second nature to you, gentlemen. Then we're going to get into sizing other things. So if I repeated myself today, Chanel, don't be scared of me. Don't be mad at me. The idea is to warm up to doing other things as we go through. We're going to have a couple of transformers, guys, problems as we continue doing, UPSs and MCCs and all this stuff. Sizing, basically. We do a lot of calculation. Okay, before you leave, your homework. Every class we're going to have a homework, guys. So homework, what, are you kidding me? Of course we're going to have a homework. Here's your homework. The homework, guys, I want you to use the same layout. I'm going to give you different voltage. Here's your homework. Right here, homework. Homework number 1. Homework number 1. Here's the system. I'm going to write it down. I have 4160 volt double slash 208 slash 120 transformer, and it has a 500 kVA with an impedance of 2%. Z is 2%, kVA equal 500. Here's your homework. And what do you need to do, gentlemen? You need to do the same thing like we did. Everything, all the 16 steps for this transformers. Anybody can tell me what's the primary?
4160.
I know, what is it, delta or Y, the primary? Delta. Why not? How do you know without drawing it? Is there another voltage here? There's no voltage, only one voltage. Is this a Y? Yes. How do you know if it's a Y? This is how you guys are going to see it. They're going to give you 2 voltages and a voltage. That's a delta, that's a Y. Okay? That's what we're going to do tomorrow. We'll do a center tab example. Okay, so this is going to be homework. Doing what? Doing 16 steps.
Is it 500 kVA for transformer?
500 kVA for a transformer. All of them. It's a bank. No, yeah, we're going to do, I have to clarify this one. Very good point. This will be huge then. I don't want to make it huge for you guys. Let's make it the kVA equal 100 kVA per transformer. Okay, thank you. 100 kVA per transformer. So the 3 of them together is what? 300. Thank you. 100 kVA per transformer. 100 kVA per transformer. The impedance is 2. Any question, my friends? Any questions? Go lunch.